Hello everyone, welcome to the project about Johan Castberg oil field. Let me introduce our team members. Бухтыгиреев Улураз, Бигдайыр Санжар, Иксбай Тамирис, Зерек Асет, Урах Нурбулат, Казиев Жантөре, and Аласханов Алас. Johan Castberg oil field, located in the frigid waters of the Arctic Ocean. Let's explore the production mechanisms that keep this operation running smoothly. First up, we have the offshore platforms. These towering structures serve as the central hubs for drilling and production activities. Equipped with the state-of-the-art technology, they extract oil from beneath the seabed. Next, we have the underwater pipelines. These arteries of the operation transport the extracted oil from the seabed to the surface facilities for processing. Once the oil reaches the surface, it undergoes a series of processing steps at the facilities. Here it's separated from impurities and prepared for transportation. Finally, we have the tankers. These massive vessels transport the processed oil to refineries around the world, where it will be turned into various petroleum products. And there we have it, the production mechanisms that power the Johan Castberg oil field, ensuring the steady supply of energy for the world. Till next time, stay tuned for more insights into the world of oil production.
So as we discussed about technological scheme and how we develop oil from our Johan Castberg oil field, I will talk about criteria. We have several criteria how we develop it. First of all, it's technological feasibility, economical feasibility, ecological feasibility, safety and ability to develop it further. Now I will discuss more in detail how we do it.
I would like to discuss our production mechanism criteria from technical feasibility, and here we meet all the standards. First of all, because we have large reserves of oil, which means building on this scheme from offshore to tankers would be worthy because it would be beneficial in the long run. Also, we have less surface impact, and it would be easy for engineers and investors to implement new technologies on offshore platform, and we have access to global market. From ecological point of view, we also meet all the standards because we leave small land footprint, we don't disturb much our wildlife, we can create new habitat on the produced field, and we have no surface contamination. From economical point of view, we also meet all the criteria because we have large reserves from 400 tons of oil to 650, and it means that our oil field would be very beneficial for us in the long term run. Also, we meet all the safety standards because our production mechanism will be hermetical and leave no traces of oil, and our ability because we are high quality engineers and we will leave no pollutants and so on.
So that will be it. Thank you for your attention.
Hello everyone. Now I want to talk about enhanced oil recovery methods which are used in the Johan Castberg field. We all know that Johan Castberg field is an offshore field. We're located in Barents Sea in the Norway, and for nowadays Johan Castberg field employs several methods of enhanced oil recovery. There are water injection. What is a water injection? It is a very common methods of oil recovery, and the purpose of this method is to inject water into reservoir for maintain pressure and improve the efficiency of oil recovery. The second method is a gas injection. Gas injection, the purpose of this method is use some gases such as nitrogen, carbon dioxide, and many type of gases. We inject these gases into the reservoir for displace oil and improve the efficiency of oil recovery. The third and the last method is the chemical method. The chemical methods, there are some polymers and alkalis and some chemical substances which we inject into our reservoir for improve the efficiency, and this method is always combined with other methods. That's all.
Screening criteria for enhanced oil recovery. Johan Castberg with improves the 5 methods. The first method with CO2, it is the method with available with alternative gas effective methods. Under measurable conditions, CO2 in the wheels of dissolved single phase. This of shows the viscosity between the oil and the gas. This is mean easily towards production with the oil. The next method allows this method combination injected water induced polymers and the salinity. The next short method with of combination. This method combines 2% and the polymer. Example with the getting polymers with oil with stable and the water increases with the viscosity. The first method in the girls, it is the girls with the react heterogeneous method. The fifth method with alkyne with the react to choose the water and the oil. This is all methods with excellence in the different ways, especially of eco-friendly, economically, and of technology.
As we chart the course for the Johan Castberg field's future, we must pivot towards more advanced, sustainable, and cost-effective production mechanisms. Facing innovation is not just an option, it's a necessity for our enduring success. Firstly, we propose the integration of digital twin technology. This virtual module simulates our field's production processes, allowing us to anticipate challenges, streamline operations, and enhance decision-making. By doing so, we can significantly reduce non-productive time and optimize production rates. Moreover, the adoption of automated drilling technologies presents an exciting frontier. The incorporation of real-time data analytics and machine learning, we can ensure precision drilling that will minimize risks and maximize reservoir contact. Looking towards sustainability, it is imperative to reduce our carbon footprint. The future lies in the electrification of our offshore platforms, sourcing power from renewable energy. This shift not only aligns with global environmental standards, but also promises long-term economic benefit. In conclusion, the future beckons with the smart fields augmented by AI, robotics, and clean energy. By implementing these next-generation technologies, we will not only propel Johan Castberg field to new heights, we will also redefine the benchmarks for the entire industry.
As you know, we have several types of enhanced oil recovery methods, for instance thermal, gaseous, chemical, and others. Each of these types or methods has its own percentage of efficiency. We choose the methods which has more efficiency than in our type of oil field. First one is alkaline surfactant polymer flooding. Is one of chemical EOR methods. So the reason is given the high salinity of formation water in the Barents Sea, ISP flooding could be a viable option. It involves injection a combination of alkaline surfactant and polymer to improve oil displacement and recovery. The second one is a steam-assisted gravity drainage, SAGD. This is one of thermal EOR, so is used due to the cold environment. SAGD could be considered for specific zones with a high oil viscosity to enhance oil mobility. And the last one is a carbon dioxide enhanced oil recovery. So the utilizing carbon dioxide from nearby gas fields or industrial source for miscible or immiscible gas injection could help maintain reservoir pressure and improve oil displacement.
One of the most essential parts of drilling to obtain oil from the field is ecological part. There are several issues and extra cases that are related to the environment, such as oil leakage from the drilled places, which causes huge damage to the surrounding sphere. One of the innovative ways to inhibit such cases is using activated coal as an absorbing material. During the spill of oil, activated coal can be directly transported to the source, where it can drain any spilled oil while damages are being repaired. After all, this absorbed oil in coal can be used for further distillation process, where we obtain oil and activated coal, which can be used again in other cases. This idea has several benefits, for instance like simplicity of processing, solving the problem, and the availability of needed materials. Process needs only transportation of coal to a spilling place where it absorbs harmful components in oil, and the activated coal is quite cheap in industry. Thus, using this method is economically cheap. Last but not least is the easy of processing of absorbed oil, which only needs separation that can be accomplished by several methods like mechanical, thermal, and etc.